right, guys, we're going to be talking about 2.2 linear equations in one variable, and in this video we're only going to be covering Roman numeral 1. So you'll have the essential question given to you later. Number 1, we're going to be talking about linear equations. So A, B, and C are all following the linear function idea. All right, so let's take a look at solutions. So let's say we have an equation and we are solving for x or solving for a variable. It doesn't always have to be x, but one of three things can happen. One of those is when you get a solution like maybe like 3x is equal to 3x, right? So the left side is equal to the right side, and you kind of get stuck here because you're like, wait, what? I'm not used to getting something like that. And so when that happens, you actually have like a true statement. So you would have a true statement, and when that true statement happens, that means it's an identity, which means there's all real solutions. All right, so it doesn't matter what number you pick for x. Let's say I pick 2. That means 3 times 2 is 6 on the left, and I also have 3 times 2, which is 6 on the right. So all real solutions are what that's going to bring out on that. All right, then you have a conditional equation, which just simply means you're going through and you have something like 3x equals 6, and you know that x only works if it's 2. So you basically only have one solution. Okay, so you'll only have one solution. All right, and then and this is kind of where we live. We live in this area right here. But occasionally we can go into what we have with inconsistent equations, which would be maybe like you go through and you solve and you get like 3 is equal to 5, right? So you're basically getting a false statement. All right, so if there's a false statement, then what that means is there's going to be no real solutions. Okay, so there's no real solutions for that. All right, so those are the types of solutions. Now let's go in to look at see what type of equations or functions that we can have. What do our equations look like so that we could kind of like graph them, right? So slope-intercept is what we should all be familiar with, right? So y equals mx plus b, where m represents the slope. And again, let's find out the slope, y2 minus y1 over x2 minus x1. So we're finding the change in y over the change in x, all right? That triangle represents change. And so we also have the b, which is the y-intercept, which is always given when the x value is 0. So now let's take a look at point slope. Now, point slope is written a couple of different ways depending on which text that you use. So it's very important to me that you pay attention to the way that we are calculating this. Okay, this is the traditional way of point slope form. Okay, now ideally you are given a point, right? So you're given the point with x1 comma y1, and you also have a way to figure out the slope. All right, so your slope is m. Now, this is what varsity learning desires, I believe. They want it like this. But what we will be doing for me is that we are going to bring this guy over. So we're going to bring this over to the other side. And so we're going to refer to this as our modified point slope. So I've got our m. Trying to switch these colors, right? So So we have our x1 point, and then what's nice about this is that we just get to add our y1. So our x and our y are right there. Now that's going to come in handy when we start working with transformations. So this is also point slope, but this is what Mrs. Allen wants. And then over here, that original one on point slope is what Varsity Learning wants. And so if you watch Varsity Learning videos, all they're going to do is have you put it in Varsity Learning's format. And you should do that for Varsity Learning, but I will refer to this version of point slope the way that I want it. So just make sure that you're aware of that. Okay, and then we've got standard form. So standard form is ax plus by equals c. And the idea behind that is finding the intercept. So what's good about this is that you have the x-intercept. As long as it's in this form, we know that the y value would be 0. So essentially what you're doing is the x-intercept is going to be found by going c divided by a, and then the y-intercept is when the x is 0, and then you would have that number divided by b. So this is just really helpful if you are graphing maybe the x and the y, and then you can plot those points right away without having to utilize slope. Okay. All right, so now let's talk about types of lines. And these usually give you the most trouble because we don't deal with them very often. So let's take a look at the characteristics of vertical lines. So if I have a vertical line, that means it's going to be going up and down. The equation is going to be x equals whatever number it is crossing that x-axis. And the slope is going to be undefined. And the reason for that is if you take a look, if you go from this point to this point, we are rising. Sure, we're rising 2. Let's say that we're going up 2, but we are not going over any number. And so if we were to rise 2 and go over none, we would have 2 divided by 0, which means that's going to give me something that's undefined. Okay. Now, contrast that with a horizontal line. Okay, so that's going to be a y equals and then a designated number. And the slope from that, let's take a look at what's going to happen with that. So I'm not going up any, so that means I'm going up 0, but maybe I'm going over 2. Well, then that means my slope is going to be a 0. Okay, just remember a little thinking cap goes on over here. It is okay for 0 to be on top. It is no if 0 is on the bottom. All right, so just a little mind trick over there just to help keep track of that. And then there's another kind of acronym here, just real quickly, and it's called HOIVUX. All right, HOIVUX. All right, now that H stands for horizontal, the 0 is going to stand for the slope. So this is the type of line. This is going to be the slope, and that is going to be the equation of the line. And then, so then that means this is going to be the type of line. This is going to be the slope, and that is going to be the equation. So HOIVUX, right? Just a little way for you to, again, just kind of keep those things straight. Sometimes you just get a little bit overwhelmed with all the different types of math things that we have going on. All right, so now we've got parallel lines. So we should know that parallel lines are like those railroad tracks, right, where they're not going to intersect. So the idea behind parallel lines, the condition of parallel lines, is that the slopes are the same, okay? Slopes are the same, but they have a different y-intercept. So they have a different y-intercept. Okay, so they're basically different lines, but their slopes are the same. Whereas perpendicular, their slopes are going to multiply to -1, which just simply means that they are opposite and reciprocals. Okay, so let's take, for example, let's say I have 7. Okay, so if my slope is 7, then the perpendicular slope would have to be a negative, right? Because it's got to be the opposite. So it's either going to, one's got to be a plus, one's got to be a minus. So if this is a positive 7, we've got to have a negative 7, and then the reciprocal of 7 is 1/7. So that if I were to multiply those, then that means what I'm getting is -7/7, which gives me -1. So I now know for sure that I have a perpendicular slope. So the slopes are going to be opposite and reciprocals.